So I'm going to be talking about the large-scale simulation of EV charging system ecosystem PKI. Excuse me, I do have to read because I get nervous. Some of you might know that currently the vast majority of standards-based charging systems being used in the U.S. rely on an unprotected TCP/IP link between the electric vehicle and the charging station, also known as the EVSE. While that might be concerning, it's not the most serious of the vulnerabilities. So I would recommend you to the session on Friday when our Oxford colleagues will discuss their work on broken wire. Nevertheless, this standard, introduced in 2014, has requirements for a domain-specific public key infrastructure to support a few cryptographic applications, namely one-way TLS, version 1.2, certificate-based automatic authentication, and XML signatures over energy metering data. That standard and its PKI turned out to be very challenging to implement for a variety of reasons. It's now being superseded and overlapped by a new version published in June of last year, 2022. Some PKI requirements were updated.
Currently, Tennessee is a leader in the manufacturing of electric vehicles, and we are seeking to be a leader in transportation and vehicle cybersecurity. The future of mobility initiatives will build upon and expand research and partnerships started by the Center for Transportation Research. Work will contribute and adapt to the rapid technological changes already underway in transportation mobility. Demand for mobility solutions that are increasingly autonomous and connected and that deliver safer, more secure performance is driving innovation across multiple sectors. This initiative boldly advances
with clear and complete requirements for technology, operation, and governance. In my previous role in industry, I was a founding co-chair of that PKI project. These are the companies and interests that were involved. And here are snippets of the PKI hierarchies from those ISO standards. Since both of them are being used in the field, the SAE group decided to support both of those sets of certificate profiles.
So my name is Kevin.
What they did was hire world-class experts in PKI to come in and design the system from the ground up to be comprehensive, extensible, and particularly to cover all aspects of technology, governance, and operations. And so that effort ended up with an implementation, a prototype, and the testing of these structures with many of the participants participating in those testing at the NREL laboratory in DOE laboratory in Golden, Colorado. Well, to help industry de-risk the adoption of PKI for EV charging, a team of engineers at Sandia and NREL have set out to simulate and model its use in EV charging infrastructure using tools and skills we developed for testing the security of cyber-physical systems at scale. And these tools are known as Mini Mega and Phoenix. Effectively, these are the screenshots that you can see from a list of virtual machines to their consoles in miniature to blowing up a console to look at what's going on. And lots of the ability to plug these virtual machines together and understand the communication that's happening between them and their interactions. So this large-scale system allows VMs to be configured, to be experimented with, and to be orchestrated for performance in these testings. I'd like to emphasize that the PKI structures and APIs and services that you see here in our mock-up are all plug-in to this environment. So what we're doing is effectively taking the PKI design, in the first instance, the SAE APIs, with agreement and cooperation of SAE International, and implementing those virtual machines that perform the certificate authority operations using an external platform where you might generate your certificates and revoke them, and all the APIs that we use to plug in there. We implement the charging standards with open source code that we're adopting to actually have the messages in that standard communicated back and forth between the entities. And then finally, you see that deployed on the large-scale clusters that we have in our labs. The initial experiments will demonstrate how the PKI under test and emulated end devices and systems respond to loss of control of a private key, for instance, or root an intermediate CA outage or compromise, massive certificate revocation, reinstatement, or renewal. These are the kinds of experiments that we can run. We'll take advantage of the cyber testing ranges hosted on this big iron in both of our labs. I'd be very happy to carry on discussions and explain more to you for the rest of this week. Thank you very much.